Now, yesterday we started talking about 1.3, transforming linear functions. We left off when we were talking about stretches and compressions. If we're going to do a horizontal stretch or compression, it is just like the last section. A horizontal stretch and compression affects the x values. So f of x becomes f of 1 over b of x. You always take the reciprocal of what the factor is. Remember, if b is greater than 1, it's a stretch. If it's 0 to 1, it's a compression. For a vertical stretch and compression, you're taking the entire function and multiplying by the stretch compression as they're telling you, the factor. Now we're talking about transformations and reflections. They change the positioning of the line. If we're talking about any stretch or compression, the x and y intercepts do not change. Where the graph intersects the line, it will always be the same. We're talking about g being a horizontal compression of f of x equals negative x plus 4. This is an example. We're going to change it by a factor of 1/2. We need to write the rule for g of x. What's occurring here? Which type of transformation? Horizontal compression. So horizontal. If we're looking at a horizontal stretch or compression, you take the x value and you multiply by the reciprocal of the factor. So what's the factor here? 1/2. So if I actually take the reciprocal of that, what's the reciprocal of 1/2? 2. So I have 2x plus 4. Your function is just 2x plus 4, negative 2x plus 4. I have the original function of negative x plus 4. Negative x plus 4. The new one we said was negative 2x plus 4. There's the first graph. There's the second graph. You have to think by a factor of 1/2. You're actually making it a little bit steeper. But it still goes through the exact same intercept. Now we're going to talk about g of x being a vertical compression with the function of f of x, or 3x, f of x equals 3x plus 2 by a factor of 1/4. How does a vertical compression affect a function? A vertical stretch takes the entire function and multiplies it by its factor. So we're going to take, for g of x, we're going to take the entire f of x and we're going to multiply by 1/4. G of x equals 1/4 times 3x plus 2. I took the entire function of f and multiplied it by 1/4. Now I distribute. What's 1/4 times 3? 1/4 times 3x is 3/4x. 1/4 times 2 is half. And that's your answer.
That's the answer?
Yes.
I like this one.
sometimes we have multiple transformations. Here we have g of x be a horizontal shift of f of x equals 3x. We're going to shift it to the left 6 units, followed by a horizontal stretch by a factor of 3. How do you do a horizontal shift? It's not a reflection. How do I shift something to the left? What happens to its function? What's the basic a basic horizontal shift? You take f of x and it becomes f of x minus h. Remember, it always has to be x minus. So we're talking about we're talking about 6 to the left. So we're taking this function here. How would I move it to the left 6? Subtract 6. So it's going to be x minus negative 6. So it becomes f of x plus 6, because the two negatives become a positive. Now I actually, because I'm doing, this is my middle function, because I have to do 2 steps. Now I substitute in what f of x was. F of x really meant 3x. So 3 times the x plus 6. When you distribute, you get 3x plus 18. We've done the horizontal or the shift of 6 to the left. Now we need to do the horizontal stretch by a factor of 3. Horizontal stretches, how does that affect the problem? How does a horizontal stretch affect the function? What's the rule? You multiply by the reciprocal of whatever your scale factor is. So the reciprocal of 4 is 1/4. So I'm going to replace with 1/4. I replaced the x with 1/4. Multiply through. Your answer is g of x equals 3/4 x plus 18.